In this quick tip, you take a look at the attachment constraint, which enables you to do tasks the link tool doesn't offer. Typically, when you want an object to travel with another, use the link tool to create a hierarchy of objects. This works well with transforms like position and rotation, but not when objects are deformed. For example, say you have a flat surface representing a pool or a pond. Give it enough subdivisions and apply a noise modifier to it. Adjust the Z strength and enable Animate Noise. If you want, you can slow down the animation by reducing the frequency value. The object is animated to deform accordingly, but it's not actually moving in the scene. Its transform values do not change, as the transform curves are actually flat at this time. The only animation taking place currently is based on the noise phase value. If you were to create another object, such as a teapot, and link it to the plane, it doesn't react to the deformation, even though it's parented. The trick then is to use the attachment constraint. Unlink the teapot, as you're about to create a different form of dependency. With the teapot still selected, choose Animation, Constraint, Attachment Constraint. With the rubber band displayed, select the plane as an attachment surface. The teapot gets relocated. To choose a better position for it, use the Set Position button and then click and drag a spot where you want it to be on the plane surface. The teapot gets relocated to that face. If you want to orient it differently, you can certainly apply a local rotation to it. As you play back the animation now, the teapot is reacting to the deformation of the plane surface. A more practical and real-world use of this tool came from a subscriber's question. If you animate a parametric pivot door in 3ds Max, how would you create a doorknob that reacts to the door opening? The answer, of course, is to use the attachment constraint. A pivot door is created by dragging the door width first, then its depth, and finally its height. You can animate its opening by animating the open spinner value. You also need a doorknob, obviously. To keep things simple, we'll use a simple sphere in this demo. You could use AutoGrid to build the sphere in place, but you don't have to. In fact, when using constraints, it is often best to use an animation helper as interim between two dependent objects. Create a point helper in box mode. Use attachment constraint to constrain it to the door in the right location. If you were to test the door opening at this time, you'll notice that the helper travels with it. All that's left is to select the knob, align it, and then link it to the point helper, and your job is done. Be mindful of one thing, though. The door is a parametric object. Changing some parameters, such as width or depth, should be okay as far as the doorknob is concerned, it still follows the face where you positioned it. Even parameters such as double doors may work out fine. Other parameters, such as height, might require a readjustment of the knob location if you want the doorknob to remain at a certain elevation. More drastically, options like flip hinge would certainly require a relocation of the knob. In that case, select the point helper, go back to the motion panel, and use set position again to relocate it. If you need some rotation adjustments, do them as well. If the knob is not spherical, you will probably need to mirror it as well.